Hi, my name is Safwan Islam, and I'm a machine learning engineer here at phData. And today I will be talking about the importance of MLOps and specifically how it differs from DevOps. Before we define MLOps and DevOps, let's start with an example. So the automobile was a revolutionary idea. It made us rethink how we get from point A to point B. But when it was first invented, companies weren't able to build and churn out cars at a volume that would actually provide value to the general public. They took too long to make. That problem gave birth to the concept of the assembly line, which created a managed and repeatable process and vastly sped up the production of cars and finally let them be consumed by the masses. From this example, we learned that to gain actual value from an innovation or an idea, you need to be able to mass produce and distribute that idea. The same can be said about machine learning. It began as a purely academic concept with algorithms being developed in the 40s and 50s. Later, it was introduced in the workforce as mostly research and development work and niche proof of concepts. Higher ups would like to see their machine learning applications in production, but didn't necessarily have the architecture or expertise to do so back then. But now today, we are at a point where we can actually provide business value and put those machine learning applications into production. So what exactly changed? Well, in a similar vein to our automobile example, we understand that machine learning is a powerful tool, but in order to provide value, we need to place machine learning managed and reproducible workflow. And that's where we introduce MLOps. So let's finally formally define MLOps. And it is the process of automating and productionalizing machine learning applications and workflows. So at this point, you're probably thinking that you've heard of a similar concept like DevOps, and you'd be right. In fact, MLOps comes from DevOps. So let's introduce that. DevOps is a set of practices that aim to shorten a system's development lifecycle and provide continuous delivery with high software quality. Simply put, both concepts aim to place a piece of software in a repeatable and fault-tolerant workflow. And MLOps, that software just happens to have a machine learning component. So really, the relationship between the two is more of a parent-child one. You can see that MLOps is an extension of DevOps. Since DevOps came first, let's cover that first. Again, DevOps aims to shorten that code, build, deploy loop. And this sounds great, but how do we actually implement it? Well, according to Google's DevOps engineers, the 5 key components are as follows. 1, reduce organizational silos. What this means is teams need to break down that barrier between dev and ops and share the ownership and accountability of actions. 2, accept failure as normal. This means that we need to embrace risk in iterative development. It's better to fail in the development phase than in production. Next, we got implementing gradual changes. What this means is that we want to be able to move quickly in smaller iterations and so that we can reduce the cost of failure. This way, it's easier to roll back changes. Next, we want to leverage tooling and automation. This one's self-explanatory, but we just basically want to automate as many manual tasks as we can. And lastly, we want to be able to measure everything. So we want to define what success is and how it will be measured for all components of a project. Essentially, we can look at DevOps as an experimental process. We try things out, we fail over and over, keep track of those failures, and eventually succeed. Conveniently, machine learning itself is very experimental and follows a lot of these same principles. With this in mind, let's take a deep dive into the key differences and nuances between the two concepts. When comparing the overall cycle of each pipeline, you can see that they're mostly the same. But as you can imagine, MLOps will consist of machine learning pieces. Those 3 main pieces include data labeling, data transformation, and algorithm selection. Data labeling is the process of adding a target to your data for the model to learn from during the training phase. Most models in the industry today are supervised, and that means they are built using targets or these labels. Data transformation or feature engineering is needed to modify the data to be in a certain format in order to properly be consumed by the model. If we don't do this, we won't really get meaningful results. And finally, algorithm selection is key for a similar reason. If we don't choose the right algorithm for our use case, we will not get meaningful results. So speaking of cycles, let's move on to the development and CI/CD side of things. Now, development takes on two different meanings in MLOps and DevOps. With traditional DevOps, your goal is usually creating an application or interface. You have your code wrapped up in an executable, and validation is done with a series of unit and integration tests. Conversely, in MLOps, the goal of the code is to build a machine learning model. Your final product will be a serialized file that you can feed data into and receive inferences from, and validation is done by checking model accuracy metrics. In both cases, these cycles are continued until you reach a certain quality threshold. Now onto the things that we need to keep track of in both pipelines. With DevOps, we really only need to version control our code and artifacts. In this case, would be an executable. In MLOps, we gotta keep track of a few more things. Aside from the code and artifact, in this case, serialized file, we also want to log the state of other key components in a machine learning project, like our data, hyperparameters, and model performance metrics every time we run an experiment. In the same manner we track code changes to be able to revert back to older code, we need to track other components to be able to roll back to older model code and older model metrics. A common scenario in which this is especially important is when auditing is being performed. We need to be able to reproduce results for every experiment conducted. Next, one component that's unique to MLOps is the concept of monitoring. And yes, DevOps has aspects of monitoring, but the specific monitoring I'm referring to is with model and data drift. After your model is built and deployed to production, the job isn't done. Data trends change over time, and while your model might be performing well today, it might be degrading later down the line. You want to make sure that your model is constantly being monitored and performing well over time. Performance can be measured by various machine learning metrics, but whichever one is chosen, we need to retrain the model if that metric falls below a certain threshold. Finally, let's discuss who does what on each side. In DevOps, we have software engineers that are developing the code, while DevOps engineers are focused on deploying, creating a CI/CD pipeline for their developers. On the MLOps side, data scientists play that role of the app developer, but they're typically writing model building code. And MLOps engineers or machine learning engineers are responsible for the deployment and CI/CD side of things, but they're also focused on the monitoring of those models in production. Here's a summary of the key differences I went through between MLOps and DevOps. And I just want to end by saying that while MLOps is important, it isn't some revolutionary idea. To formally summarize and answer the question of this topic, MLOps is just a specific implementation of DevOps.